Okay, everyone, what we're going to do is apply some right triangles. Now, we started this in class, but I decided, you know what? Let's do a couple of the ones that I signed for homework. That way, that'll give you a chance to check your answers before we come to class. Anyways, here we go. So this is problem number 4, and they're talking about a 20-foot ladder leaning against a building. So again, remember guys, what we're going to do is we're going to draw a picture, right? So let's say here's my building, here's the ground, it's just a sketch, doesn't have to be perfect, and we have this ladder leaning up against the building. What else we're told? The angle between the ground and the ladder is 72 degrees, so that'll be right there. That's 72 degrees right in there. That's the angle between the ground and the ladder, right? And they want to know how high will the ladder reach on the building. So basically, they want to know what this is right here. That's our question. So we might as well call it H for the height, right? But you could call it X or any letter you want. So what else do we know? Oh, it is a 20-foot ladder. Can't forget that. So now we have all the information we need. Notice that the missing height is opposite with our 72-degree angle. And notice that this 20, in essence, is our hypotenuse. So according to SOHCAHTOA, what uses opposite hypotenuse, right? If I do SOHCAHTOA, which one uses opposite hypotenuse? It's sine. So therefore, I know I'm going to say that the sine of 72 degrees must equal H over the 20. Again, I'm going to do the opposite, which is missing, over the hypotenuse 20, that's sine. So from here on, guys, all I need to do is use a calculator, right? I know that the sine of 72, let me just set it up here. So notice that all I need to do now is times both sides by 20, and I'm going to get the height, right? So basically, I'm just going to take 20 times the sine of 72. So as I showed you here, I have the sine of 72. I'm going to times that with 20, and I know the ladder is going to reach up to a little over 19 feet. So we just figured out 19 point, and then of course, well, if we keep 2 decimal places, it'll be 0.02. If we round off, it will be 19.0. So we'll just do 19.02. But in essence, this is basically 19 or 19.0 feet. So from here to here, we know is 19 feet. All right, that's number 4. Let's go on to number 5. So number 5, we have a 96-foot tall tree. So imagine here's the ground. Here is our tree. This is a big tree, right? 96 feet tall. 96 feet tall. So here's our big, huge tree. We know it's 96 feet tall. Here's going to be our triangle, you see. Now, it casts a shadow of 120 feet. So imagine the sun over here. It's going to shine down, and it's going to make a right triangle. In other words, it's going to just, the rays are going to shine down, and then right here on the ground, shown in green now, is going to be its shadow, right? Shadow of the tree onto the ground. Now we know it's 120 feet long. Our tree is 96 feet tall. They want to know the angle of elevation of the sun. In other words, we're standing over here at the edge of the shadow, and we're looking up at the sun above the tree, right? We want to know this angle of elevation. Remember, when you're looking upwards, it's elevation. When you're looking downwards, it's depression. Okay? But anyways, if we're looking at theta here, I hope you agree that the tree is opposite of my angle. and this 120 is adjacent to my angle. So what uses opposite adjacent? What uses opposite adjacent? TOA, right? So tangent. So I now know I'm going to do the tangent of theta equal to opposite over the adjacent. And now, guys, what I'm going to do is take my calculator, I'm going to divide this into a decimal, and then I know that if I do a tangent inverse on it, -1 power is not really power, it just represents inverse, right? I'm going to cancel out my tangent, and I'm going to get theta. So theta, in essence, is the tangent inverse of 96 over 120. So as you can see right here, 96 over 120 is exactly 0.8. I do the tangent inverse. So on my calculator, guys, that means you would do shift tangent. Okay, that's how you would get this tangent inverse. But anyways, if I do tangent inverse of that 0.8, I know my angle is 38.659. So we'll round it off. This 5 means that the 6 rounds up one spot to 38.7. So we know that this angle theta right here is 38.7 degrees. Now when we get to guys, we're going to do number 6 and move on to the next lesson.